Hello everyone, welcome back to Infinity Physics. In this lecture, we are going to derive the equations of motion using graphical method. So to derive these three equations of motion, we need some data, and this data will help you to derive all these three equations. So in the data, initially we have the object which is moving with some initial velocity. It is not at rest, it is already moving, and for that object we are plotting a velocity time graph. So here the object already moving with some speed, and then it accelerates for some time t. Then after some time t, the object acquires some velocity. For example, initially the object is moving with 10 meter per second. Then it accelerates uniformly and acquires the velocity of 30 meter per second. So after time t, it will acquire some velocity. That is, this y-axis indicates the velocity and this x-axis indicates the time. So after some time t, it acquires some velocity v. So this is the velocity v which is acquired, and this is the initial velocity, right? So initial velocity was suppose from 0 to 10 meter per second. Then the final velocity is from 0 to 30 meter per second. So this indicates the final velocity, this indicates the initial velocity, this particular line indicates the time, and this slope indicates the acceleration. So let an object moving with initial velocity u, it then accelerates uniformly and changes its final velocity to v in time t. So from graph we have OA, means this is the initial velocity and this is the opposite side of this imaginary rectangle. And how this form? See, this is the graph only. In this graph we have just drawn a dotted line. These all dotted lines are just to make the derivation simple. So here we have drawn this line perpendicular to x-axis, another line perpendicular to y-axis, and here this line also perpendicular to y-axis. So here we have OA, it's the initial velocity, that is u, and which is also equal to this line DC or CD. So we have OA is equals to CD, which is the initial velocity of the object u. Then OE, where is OE? This. So this indicates the final velocity. So OE, which is equals to this line CB. So we have CB, which is final velocity v. Similarly, we have OC, this time which is also equal to the line AD. So here we have OC is equals to AD is equals to, this OC indicates the time in which it acquires the velocity. So OC is equals to AD is equals to time t, and then we have this BD. Now BD, so if you find this, what is BD? It is CB. If you minus from CB, if you subtract this CD, from CB, if you subtract this, then you will get this part BD. So BD is equals to CB minus CD. CB minus CD. Now what is CB? CB is the final velocity, and minus what is CD? CD is the initial velocity. So u, so we have BD is equals to CB minus CD is equals to V minus u, and this slope AB is the acceleration. Now why it is acceleration? See, you have find the slope, you are finding the slope in mathematics, right? So in mathematics, how you find the slope? Like this, you draw the two lines. So this line here, I have this two line, one line is perpendicular to x-axis and another line is perpendicular to y-axis. So this lines, the ratio of this line will give me the slope, and that slope is the acceleration. So here v minus u, this v minus u, and this is t, this AD is t. So what is v minus u by t? It's a acceleration. So I can say that slope gives me the acceleration. So let us derive the first equation of motion, which is also known as which is also known as velocity time relation, which is also known as velocity time relation or first equation of motion. So to derive that equation, we know that acceleration is equals to change in velocity by time taken to change that velocity. So A is equals to change in velocity. See, we have to use the data from the graph. We cannot put directly V minus U by T. So change in velocity means final velocity minus initial velocity. Now what is final velocity here? CB, or we can write the BD indicates the change in velocity. So BD minus time t. T is here OC. So OC. Also we can write BD. BD is equals to CB minus CD, and that is equals to V minus U. So now we can write V minus U. And what is OC? So OC means this time t. So time t. Now if you just change these sides, if you take this t towards left side, then AT is equals to V minus U. Now if I take this minus U towards left side, then it becomes U plus AT is equals to V, or I can write V is equals to U plus AT. Both are same. So this is the first equation of motion, which is velocity time relation. Why it is called velocity time relation? See, V is equals to U plus AT. So here the initial term is velocity. So here velocity, and here the final term is time. So it is velocity time relation. Right? So this is a simple way to remember this equation, that this equation is called velocity because initial letter is V and final is time t. So it is velocity time relation. And in terms of physics, why it is called velocity time relation? Because the velocity is changes with time. That's why it is called velocity time relation. Now in simple way, if you want to derive, then you can use V is equals to A is equals to V minus U by T. This is the equation of acceleration. So here AT is equals to V minus U. So V is equals to U plus AT. So this is a three-step derivation which is very simple, but this derivation is using the graphical method. Now let us derive the second equation of motion. Second equation of motion is known as position time relation. To derive the position time relation, we need to understand one thing that will be also helpful in the third equation of motion. So suppose you have an object which is moving with uniform velocity. So if you make a velocity time graph for that object, then you will get a line which is parallel to time axis. So here, if this is O, this is A, this is B, and if I join this line, then I will get here D. Now suppose I want to find this area of this rectangular shape graph. I want to find the area of that graph. Then I will get OA, that is area of graph, is equals to OA into, it look like a rectangle, so it is OA into OD. Now what is OA? OA is the velocity, uniform velocity, and what is OD? OD is the time. Here velocity into time. That is, the area under this graph will give us the product of velocity and time. Suppose for the another case, we have velocity is equals to total distance or total displacement per unit time. Now if I make S as a subject, then S is equals to velocity into time, or distance is equals to speed into time. So here speed into time or velocity into time give us the distance or displacement. So here velocity into time gives us the area. Here velocity into time and here velocity into time, right? So if these two terms are equal, then this area will give us the distance covered by the object. So we can say that the area under the velocity time graph give us the product of velocity and time, and which is equal to the distance covered. So what we know here, that area under, see under, area under the graph. So under velocity time graph gives distance covered by the object. Now using this fact we can derive the equation. So here the graph is little bit different, but again if you find this area, see this is the graph. So this area is under the graph and this area is above the graph, but what we want the area under the graph. So this area under the graph will give us the distance covered. So the second equation of motion is a position time relation or distance time equation. So in this equation we need the distance covered by the object. Now using this fact we can derive the equation. So in this graph what we have, we can write S is equals to, that is the distance covered, here you can write distance S is equals to area under velocity time graph. Now the area under this graph is like a trapezium. See, this is like a trapezium. Now this trapezium can be divided into two parts. One is a rectangle and another is a triangle. So area under velocity time graph, area, what is the area here? It is the area of, or we can say area of, see this trapezium can be divided into two parts. One is a rectangle and another is a triangle. So here area of rectangle, which rectangle here? OADC plus this area plus the area of this triangle, this particular triangle, right? So area of the triangle, what is the triangle given here? ADB. So ADB. So we can write area of triangle ADB. Now what is the formula for the area of rectangle? It is OA into OC plus, what is the area of triangle? The formula for the area of triangle, it is half base. What is the base here? AD. And what is the height? BD. So here we have area of rectangle, that is OA into OC plus area of triangle which is base into height, so AD into BD. Now OA, what is OA? OA is the initial velocity u into, what is OC? OC, here OC, what is it? It is time t, so t plus half. What is AD? Where is AD? So here AD is the time into BD. What is BD? BD, where is it? Where it is? Here, V minus U. So here we have V minus U. Now if you elaborate this equation properly, then we will get S is equals to UT plus half T. Now what is V minus U? We have equation A is equals to V minus U by T. Now if I make V minus U as a subject, then I will get AT is equals to V minus U. Right, here I have just taken T this side. So I can write, instead of V minus U, I can write AT. So here I can write A into T. So this can be modified and write UT plus half A T into T. So A T square. So here our final equation for position time relation, which is also known as second equation of motion. So here this S indicates the position and this time indicates the time in which this distance covered, and hence it is known as position time relation. Now let us derive the third equation of motion. Now to derive the third equation of motion, we again need the same fact that the area under the velocity time graph gives the distance covered. So the third equation of motion, which is also known as position velocity relation. So here S is equals to, that is the distance covered by an object, is equals to area under velocity time graph. Right? Now this area, it's look like a trapezium again, but we will not divide this into two parts. Now we will consider whole as a trapezium. So here we have area under, or we can say area of trapezium. So this is the trapezium here. Here we have this kind of trapezium. This is O, A, then B, and then here we have C. So what is the formula of the trapezium? Area of trapezium is equals to sum of parallel sides, sum of two sides, or sum of parallel sides. In my words, I generally consider it as a sum of parallel sides into distance between parallel sides. See, these two sides are there which are parallel to each other, so we need to add them and then multiply it with the distance between them. So distance between parallel sides, divide by 2. So this is the same formula that you learn in the mathematics, but I consider it in my way. So here sum of parallel sides. So here this OA plus BC or CB into distance between parallel sides. What is the distance? OC. So OC is the distance between the two sides. So here OC divide by 2. So here what is OA? So here S is there. So S is equals to, what is OA? OA is initial velocity U, plus what is CB? CB is the final velocity V, into what is OC? OC is here time taken T. Now if we modify this time T, then we can get the final equation. Now from the formula of acceleration, we have A is equals to V minus U by T. This is the formula of acceleration. If I make T as a subject, then T is equals to V minus U by A. So if I put this value of T here, then in the last step we can get the equation easily. So let us try to derive it. So here S is equals to this as it is, V plus U. Instead of U plus V, I can write V plus U, both are same. Then T, so T is equals to, I can write V minus U by A. Now this equation, and here we have 2, here we have 2. So here we have 2A. V plus U, V plus U, V minus U. So instead of T we can write V minus U by A. So V minus U divided by A. Now if I take this 2A towards this side, then I will get 2AS is equals to V plus U, V minus U. It's look like A plus B, A minus B. So it is identity. So A plus B, A minus B is equals to A square minus B square. So here I can write V square minus U square. So this is the final equation. So here we have position and here we have velocities. So this equation is known as position velocity relation. Now in the next lecture I will guide you how to solve the numericals related to all these three equations, and also we will solve numericals related to average velocity, average speed and other numericals. Have a nice day.